Okay, now let's write the hb underscore top module code. So we have input h clock and input reset in and input enable and input 31 down to 0 data underscore in underscore a, and we have input 31 down to 0, that is 32-bit input, 32-bit data underscore in underscore b, and we have input 31 down to 0 address, that is 32-bit address, and we have input write and input 1 down to 0, that is 2-bit slave underscore select, and we have output 31 down to 0 data underscore out. So these are the inputs and outputs for our module, and let us take some variables as wire type, that is 1 down to 0 select and wire 31 down to 0 h address, and another variable wire h write and wire h period, that is wire h protect, and wire 2 down to 0 wire 2 down to 0 h size. This h period is 4-bit, so 3 down to 0 h period, and h size is 3-bit, that is 2 down to 0, and we have wire 1 down to 0 we have another signal of 3-bit, that is h burst, and wire 1 down to 0 h trans, and wire h mask lock, and wire h ready, and wire 32-bit hw data. Now let's instantiate ahb master. So ahb underscore master h clock, I'm using named association dot h clock of h clock dot h reset n of h reset n dot enable of enable, and dot data underscore in underscore a of data underscore in underscore a, comma dot data underscore in underscore b of data underscore in underscore b, and address for address, and dot write of write, and dot h ready out, we are making it connection to h ready out, and h response to h response, and hr data to hr data, and slave underscore select to slave underscore select, and we also have select to select. These are the outputs, h address to h address, and h size to h size. These are the outputs for our ahb master. You can see in our previous videos we have declared this as our output. So these are my master signals. Now let's declare our slave signals. Here we have four slaves, so let's write the four slave signals. Slave underscore 1. We have wire h ready, wire hw data. We have wire 31 down to 0, hr data underscore 1, and wire h ready out underscore 1, and we have wire h response underscore 1. So these are the signals for slave 1, and similarly for slave 2, let's declare signals. So these are the signals for slave 2, hr data underscore 2, h ready out underscore 2, and h response underscore 2. Now let's declare for slave 3. Sorry, this is 32 bits, so 31 down to 0, 31 down to 0, and this is 31 down to 0, and this is slave 4. Now let's declare the signals for our decoder also. So for decoder, we have wire h select underscore 1, wire h select underscore 2, wire h select underscore 3, and wire h select underscore 4. And similarly, let's declare for our multiplexer module also. Multiplexer where 32-bit HR data, and we have H layout, and we have response. Now let's instantiate our decoder. Here the instance name is master, and here our instance name is decoder. Yeah, we have instantiated our decoder. Now let's instantiate our slaves, our four slaves. First hb underscore slave 1, I've instantiated my slave 1. Similarly, for slave 2 and slave 3, slave. Next for slave 3. And for slave 4. Now let's instantiate our multiplexer. So yeah, this is the Verilog code for our AHP underscore top model. I have instantiated multiplexer and four slaves and the decoder and the master. So yeah, this is our hierarchy. In AHP top we have master, decoder, slave 1, slave 2, slave 3, slave 4 and multiplexer.